Hello students, good morning. Good morning everyone. Good morning Nagireddy. Good morning. Shushrut, good morning. I hope all are good. Students, as I told you in today's session, we are going to start hybridization. It is most important topic in chemical bonding. In last few classes, we have studied about chemical bonding, important bonding, I mean like covalent bonding we have studied, ionic bonding we have studied, and formation of sigma bond and pi bond, and we have compared various characteristics of sigma and pi bond, and at the end we have discussed few examples in counting total number of sigma and pi bonds. Okay, so before going to start the hybridization, we need to talk about Dative bond. After completing Dative bond, we will continue discussion about hybridization. Okay, so I hope everyone is with the book, notebook, and have pen. Try to note down the important points which we are delivering here. It's better to note down the important concepts. I hope you have counted total number of sigma bonds and pi bonds which I have given in the last class, right? So let's start the discussion about coordinate covalent bond. Shall we start? So students, please focus on the class and listen carefully and follow the lecture properly, and try to give responses and don't waste your time with unnecessary chatting, right? Fine. Dative bond, it can also be called as coordinate covalent bond, it can also be called as semi-polar bond, it can also be called as donor acceptor bond. You need to know about all these terms properly. Sometimes we can use Dative bond, and sometimes we can also use coordinate covalent bond, and we can also use the term semi-polar bond and donor acceptor bond also. As we are talking about covalent bond, just a second. In covalent bond, let's say bond between A atom and A. Okay. Consider two atoms are coming close together and with electrons, as I told, with opposite spins. These two atoms are combining together and forms a covalent bond by mutual sharing of electrons. So this bond can be represented as A. Okay. So in order to make the bond between two atoms, the contributing atoms has to provide one electron each. Okay. Here, if I am making the bond between A atom and the other A atom, that is formation of A2. In formation of A2, each atom is contributing an electron, and after contributing one electron each, the two electrons are shared equally between two bonded atoms. So therefore, the bond which is formed by mutual sharing of electrons is called as covalent bond, and in this covalent bond, both the atoms which are involving in the bond are contributing one electron each. Whereas in case of Dative bond, let us assume the formation of Dative bond between atoms, let's say A and B. Consider A atom has 2 electrons and B doesn't have any electrons for contribution of bond. So B is having a vacant orbital and A is having an orbital with 2 electrons. In this case, assume the bond which is expected to be formed between atom A and atom B. Here A atom has pair of electrons and B atom has a vacant orbital. It means there is no electron for contributing or contribution. In this case, A is providing its 2 electrons for bonding between A and B, and consider the bond is formed between A and B atom, but in this case the 2 electrons which are required for bond which is provided by one of the bonded atom, and sharing can be done by both the atoms. Okay, what is the main difference between covalent bond and Dative bond? The main difference is in covalent bond, both the atoms which are involved in bonding are contributing one electron each. Whereas in the case of Dative bond, one of the atom is providing 2 electrons which are required for bonding. Once after formation of bond, the sharing of electrons can be done by both the atoms. I hope this point is clear. What is the main difference between covalent bond and coordinate covalent bond? In covalent bond, 2 atoms have involved. Even in Dative bond also 2 atoms have involved. So what makes the difference between covalent bond and coordinate covalent bond? The only difference is contributing atoms or contribution of atoms by the bonded atoms. In case of covalent bond, both of the atoms are providing 1 electron each. But when it comes to the Dative bond, one of the atom is providing 2 electrons which are required for bonding. Okay. Let's move on to the discussion about the Dative bond. A few important points we'll study about the Dative bond. So what are the important conditions for formation of Dative bond? As I mentioned already, the first and foremost condition is one of the atom should have excess electrons. In last class I explained about the non-bonded electrons. The non-bonded electrons means the electrons which are not involved in bonding and which remains as lone pairs. Okay. Here one of the atoms should have excess electrons. These excess electrons can also be called as non-bonded electrons, right? These non-bonded electrons can also be referred as lone pairs, right? Have you got this point? Have you got this point? Here we are considering the bond between A and B. A is having excess electrons. These excess electrons means the electrons which are not involved in bonding. These electrons can also be called as non-bonded electrons, or we can also call them as lone pairs. Okay, fine. Now, what about the case of the other atom? When I am referring the excess electrons means, let me write this point also. Excess electrons means after satisfying octet rule. Okay, if any atom is trying to provide the electrons or trying to donate the electrons, it must be satisfied with octet. I'll give some examples. In such cases, even though if the species contains lone pairs, it can't be able to donate. But when I can donate electron, a simple logic, okay, I need to fill my stomach, okay. So after satisfying myself, I'll try to share with some other fellows, okay. I must satisfy the octet rule. After satisfying octet rule, I can share my electrons for bonding. I hope this point is clear. The second atom, what about the second condition? Second condition, as I told, the other atom, it means the second atom. Consider, say here, say B in the context which I explained. Okay. So one of the atom, let's say for condition number 1. For condition number 2, other atom, say atom B, should be having vacant orbitals. Right? I hope this point is clear. Okay. So one of the atom is having excess electrons, the other atom should be having vacant orbital. Okay. Fine. Now let us consider the example formation of one important compound. Let's say I have to explain about the bonding, dative bond in between these two species. Example, consider BF3. Okay, in BF3, boron is surrounded by 3 atoms. Okay, if you consider the total number of bonded electrons which are surrounded by boron are 6. Okay, so in the valence shell of boron, I mean to say in BF3, the total electrons which are surrounded by boron are 6. It is in short of 2 electrons for attaining noble gas configuration. When it comes to the ammonia, here let me write ammonia here. In ammonia, if you talk about ammonia, let's say this is ammonia. If you talk about ammonia, ammonia has unshared electron pair. Okay, and if you count the total number of electrons which are surrounded by nitrogen in ammonia, we have in total of 8 electrons. Okay, nitrogen has octet. Octet is satisfied. But in case of boron, octet still it has not satisfied, since boron is having only 6 electrons in the valence shell in BF3. Okay. Now tell me students, now tell me, here boron requires electrons and it is having vacant orbital, and nitrogen has excess electrons. I say excess electrons means, as I told you, when I can say excess electrons after satisfying octet rule, I can say this as also lone pair, or I can say unshared electron pair. Now, I think the two conditions which are required for the formation of coordinate covalent bond have satisfied, right? Okay. Now, one of the bonded atom is having vacant orbital, the other atom is having excess electrons, I mean to say lone pair or unshared electron pair. Now, if the nitrogen can provide its electrons for bonding between two atoms, then we can expect the day-2 bond formation between nitrogen of ammonia and boron of BF3. So, BF3, let me write in this way, and ammonia. So, since nitrogen is providing its electrons for bonding. In this way, we can expect the formation of day-2 bond between BF3 and NH3. I hope this point is clear. Have you got this point? Was it clear? Was it clear? Students, tell me answers. Was it clear? Was it clear? Shall we move on to the discussion about the examples for day-2 bond? Condition was satisfied and we make the bond. Okay. Clear? Okay. Shall we discuss about few more examples? Here the bond between boron of BF3 and nitrogen of ammonia is a day-2 bond. Okay. Day-2 bond can be represented with this arrow mark. Arrow is pointed towards the boron. So, who is donating electrons? Since nitrogen is donating electrons, the arrow or head of the arrow is represented towards the acceptor atom. This is acceptor atom and this is donor atom. That is the reason why this bond can also be called as donor-acceptor bond. We can also call this with another term. The one who is donating electron pairs can also be called as Lewis base. What do you mean by Lewis base? Electron pair donor. Electron pair donor. Any species or any atom which is able to donate electrons is called as Lewis base. The atom or the group which is able to accept the electron pairs, electron pair acceptor, as I have written already. This electron pair acceptor is also called as Lewis acid. Okay. So, Lewis acid means electron pair acceptor. Okay. Move on to the next example. Let's discuss about the formation of NH4 positive. NH4 positive. NH4 positive or ammonium ion formation. Now, as we know, ammonia has a lone pair or unshared pair of electron, and H plus, as we know, H plus is deficiency in electrons. There is vacant orbital. Here one of the, if I am talking about ammonia, in ammonia one of the orbital is with paired electron. This is called as lone pair, orbital with lone pair. One of the orbital is with lone pair, and the atom which is vacant, right? Now, I can say this is donor atom. Why it is considered as donor atom? Since nitrogen, one of the orbital is with lone pair, and this can be considered as acceptor atom since it is having a vacant orbital. If I can use this pair of electrons to hydrogen for day-2 bonding, I can represent the day-2 bond between nitrogen and hydrogen with this arrow. Okay, and that is the reason why we can also represent the ammonium molecule with the sign NH4 positive. In the same manner, let's talk about the formation of H3O plus. This is called as hydronium ion. Hydronium ion. Okay. In formation of hydronium ion involves the same principle. Now, if I am talking about water, water has two lone pairs and the hydrogen has a vacant orbital. Let me write in this way. One of the orbital of oxygen is having lone pair, and in case of proton or H plus, the orbital which is vacant. Now, if I can use the lone pair of oxygen for dative bond, the formation of dative bond can be written in this way. Okay. So, I can also represent the dative bond in this way. If I want me to write the charge, I can represent the overall species charge with charge. I can write in this way. I hope these examples are clear. Okay, right? So, ammonium formation I have given, and formation of hydronium also I have given, right? And let's talk about few more examples. I hope you are following. So, here the conditions, I have given only two conditions. Okay, let's say if two atoms are involving in the bonding, one of the atoms should have lone pairs or excess electrons, the other atom should be having a vacant orbital. If you want me to illustrate in this way, I can illustrate in a simpler way. Consider two students, okay? Two students for covalent bonding and dative bond. I used to illustrate like this. If it is able to connect, you can remember in this way. Okay, number one. Okay, listen carefully. Students, listen the class properly and don't be distracted with unnecessary chattings. Okay, attend the class properly, focus on the class properly. Okay, right. So, I have considered two students. Student A is having, let's say, 100 rupees and student B is having 100 rupees. Okay, so both wanted to purchase 200 rupees chocolate and share equally. Okay, student A is contributing 100 rupees, student B is also contributing 100 rupees. Both collected 200 rupees and purchased 200 rupees chocolate and they have shared equally, right? This is considered as a covalent bond. In covalent bonding, both of the contributing atoms are providing one electron each. When it comes to the dative bond, consider student C and student D. Student C is having 200 rupees now and student B doesn't have any money. But student C and D wanted to eat 200 rupees chocolate. What they have to do? They must come to an agreement that D try to say like this to C, I am poor in electrons. Can you share electrons of you for bonding, so that when I am trying to share, when we are sharing both the electrons equally, then your contribution comes to you only, I will also be benefited. Okay, it is not chocolate question, I will give chocolate question. I hope this point is clear. Student C is having 200 rupees now and student D is not having money now. Both wanted to eat 200 rupees chocolate and C is kind enough to donate its 200 rupees for sharing between C and D. Both purchased 200 rupees chocolate and shared equally. I hope this point is clear. Okay. So, in first case, student A and B are contributing 100 rupees each. But in second case, only C is contributing 200 rupees and D is not contributing any money. But both are collectively taken the chocolate and shared equally. Fine? Right. Okay. Now, let's move on to the discussion about another example. Example number, I think 4. Let's talk about CO. Okay. Students, I have to introduce one important point under this example. Consider here, let's say carbon is having in total of 4 electrons in its valence shell, right? Oxygen is having, let's say, how many electrons? 6 electrons. Okay, listen carefully. Here are writing Lewis dot structures also. I will help you how to write the Lewis dot structures. The purpose of, like as I told you, each and every atom will try to have 8 electrons in its valence shell. So trying to have 8 electrons in its valence shell is considered to be octet rule. As we have discussed, attaining octet is the sustainability of the atom in the form of molecule. For attaining stability, atoms involved in bonding, if they are involving in bonding, they will attain stability by achieving octet of electrons. Okay. Now consider two bonds between carbon and oxygen. For a single bond, as I told, C is providing 1 electron and even oxygen is also providing 1 electron. This is a single bond. And for the next bond, again C is providing 1 electron and Y is also providing 1 electron. Now let's talk about the Dative bond. Now if I wanted to say, if oxygen is providing its 2 electrons now for bonding between carbon and oxygen, let us try to make the bond. As I told, already 2 bonds are there in between carbon and oxygen. Now the third bond which is formed between carbon and oxygen is involving again 2 electrons, but those 2 electrons are provided by oxygen. Now carbon is still having 2 electrons as unshared, and even oxygen is also having 2 electrons which are unshared. The unshared electrons remains as lone pairs. Even oxygen is having 1 lone pair. I can represent the bond in this way. 2 normal lines which are representing covalent bonds. The third bond is a Dative bond which is expected to be formed between oxygen and carbon. Now here the contribution of atoms for bonding makes the difference. Now in the third bond, here oxygen is providing its 2 electrons for bonding. Therefore in carbon monoxide, there is 1 Dative bond. Have you got this point? The third bond which is formed between carbon and oxygen is a Dative bond. The rest of the 2 bonds, as I told, these are normal covalent bonds. In CO, there is 1 Dative bond, the remaining 2 bonds are covalent bonds. 2 covalent bonds we have and 1 Dative bond. Let's continue discussion about the compound which is given as NiCO4. Can anyone tell me the total number of Dative bonds which are present in this given compound? I need to know the total number of Dative bonds. Anyone please? Dative bonds, total number of Dative bonds and total number of covalent bonds. Total number of Dative bonds and total number of covalent bonds in this particular compound. Anyone please? Total number of covalent bonds. Anyone please? Anyone please? Total number of Dative bonds and covalent bonds in the given compound. Anyone please? Anyone please? I have carbon monoxide, 4 molecules I have given. These 4 carbon monoxide molecules are bonded to nickel. Okay. Answer please, answer please, answer please. Anyone, you can give the answer. It is calculated question. Yeah, you can count the total number of Dative bonds and covalent bonds in the given compound. Okay, people are giving answers. Yeah, some more responses, few more responses, please. Try to count the total number of covalent bonds and dative bonds in the given compound. Okay, let's try to count. Here if you observe carefully, there is nickel. Okay, as I told, carbon is having a pair of electrons. The pair of electrons of carbon is donated to the vacant orbital of nickel. In that manner, we have in total 4. Okay, if you want me to write here the division of bonding, I will try to write 3 bonds. Out of 3 bonds, one of the bond is dative bond again, and let me write with the representation of bonding. Okay, right, and next. If I am trying to write the division of bonding over here, now tell me students, how many dative bonds are present totally in this given compound? How many dative bonds are there? I think you can write the answers now. Now this is again a dative bond, and here it is a dative bond and dative bond. How many dative bonds we have? How many dative bonds we have? Totally dative bonds, number of dative bonds, 1 and 2, 3, 4, 5, 6, 7, 8 dative bonds I have. How many dative bonds I have? 8 dative bonds. How many normal covalent bonds we have? 2 here, 2 and 2 and 2. Total number of covalent bonds are 8. I hope this point is clear. Okay, here number of dative bonds is 8 and even number of covalent bonds is also 8. Here in this particular case, my dear students, tell me, this dative bond is considered as a pi bond, but this dative bond is considered as sigma bond. You can count the total number of sigma and pi bonds also in this example. Students, response please. The other students, yes, definitely I will give chocolate when you are coming for classes into the campus. Okay, sure. Right, good. Have you got this point? Some of you guys have raised this question, I think in last class. Okay, dative bond can it be a sigma bond or it is a pi bond? Now with this we can conclude dative bond, yeah. Dative bond can be a sigma bond or it can also be a pi bond. Okay, now if I am talking about the dative bond over here, in case of carbon monoxide, if you talk about the dative bond, here this is sigma bond. As I told, out of 3 bonds, if you find triple bond between 2 atoms, one of the bond is sigma bond, one sigma bond, and rest bonds are pi bonds. Okay. Now if you consider the bonding between carbon and the nickel, okay, this bond could be a dative bond, but this bond is considered as a sigma bond because the first bond which is formed between any 2 atoms is sigma bond. Okay, students, I think no confusions, right? Here nickel has vacant orbitals. We have a chapter named as complex compounds. In complex compounds chapter of your 12th course, we will discuss about all these details. This compound is in fact called as a complex compound. This is a complex compound, or it can also be called as coordination compounds. Coordination is used to refer the bond between metal and this species is considered as a dative bond. I hope this point is clear, right? Yeah, good. One more question of the same type I wanted to write. Okay. CrCO 6 times. Can anyone tell me the total number of dative bonds in this example? Okay, and then last one more example I wanted to give. CO, let's say NH3 6 times. Let's say I have given a compound. Okay, can anyone tell me the total number of dative bonds over here? Dative bonds in this particular compound. And second one, normal covalent bonds. In the same manner, here total number of dative bonds I need, and I need even the covalent bonds also. Right? Yeah, try to answer this question. Try to answer the questions, I think F and G. Okay? It is almost similar type of question. Now you can say, as I told you, this is considered as central metal, and this is considered as a Lewis base. As we know, the species is able to donate its electron pairs to the metal. As I told, this is having the lone pairs. The lone pairs are donated to the species who is having vacant orbitals. Now tell me, students, here total number of dative bonds. So here 6 bonds are between the carbonyl group, carbon monoxide group and chromium 6, and within each CO we have 6 dative bonds. In total number of dative bonds in the given compound is 12. Then tell me how many total number of covalent bonds we have. Okay, very good. Even the covalent bonds is also, count is also coming as the same number. Good. Now when it comes to this example Z, how many dative bonds are expected to be between metal and ammonia? How many dative bonds? As I told, ligand. Okay, let me introduce this term also. Ligand is a species which is capable of donating electron pairs, species which is able to donate electron pairs to the metal. As I told you, any species which is able to donate electron pairs is considered as I told, Lewis base. Therefore, ligand is considered to be Lewis base. Then who is Lewis acid over here? This is accepting electron pairs, electron pair acceptor, hence this metal is considered as Lewis acid. I hope this point is clear. Lewis acid. Have you got this point? I think you are able to count the total number of dative bonds and the total number of covalent bonds. Fine. Okay. Clear? Have you got these points? Are you able to count the total number of dative bonds and covalent bonds? Will you be able to differentiate between total number of, dative bond and covalent bond? Yeah, tell me how many covalent bonds are present. Tell me total number of dative bonds. Total number of dative bonds is pretty clear. Each ammonia is able to donate one lone pair. Therefore, total number of dative bonds between metal and this I told you as a ligand, or it can also be considered as Lewis base. Here 6 Lewis bases we have. All these 6 Lewis bases will try to make the bond with the metal, and total number of dative bonds are 6 here. Have you got the number 6? Dative bonds, number of dative bonds are 6. Okay. Now total number of covalent bonds. In ammonia, how many covalent bonds are present? In ammonia, 3 covalent bonds are present, right? Each ammonia has 3 covalent bonds, and 6 ammonia we have 6 times that of 3. In total 18 covalent bonds are present. Just check out, Anish, Anshal, check out once. Total number of covalent bonds. Total number of covalent bonds present in each ammonia is 3. Now 6 ammonia we have. In total 6 times that of 3. totally 18 covalent bonds we have. Okay. Right? Very good. Now at the end I will give one more question. Try to answer this question properly and try to give the correct answer for this question. Okay? Are you able to get the total number of dative bonds and sigma bonds given in a okay? Right? Very good. Superb. Now so at the end I wanted to give an example. Please try to count the total number of covalent bonds and the dative bonds in this particular example. And again this compound is called as a coordination compound. As I told you, in coordination compound there is central metal atom. Central metal atom has vacant orbitals and which is able to accept electron pairs. The species which is able to accept electron pairs is called as Lewis acid. Now the group of atoms or a species which is bonded to the central metal atom is called as ligand, and this species is able to donate electron pairs. The species who is able to donate electron pairs is considered as Lewis base. Okay. Now as we know, each ammonia has a pair of electron which is not involved in bonding. The pair of electron which is not involved in bonding can also be called as a lone pair. Since it is having a lone pair and central metal atom is having vacant orbitals, I think the conditions which are required to form or make a coordinate covalent bond was satisfied. One of the atom has lone pair, the other atom has vacant orbital, hence we can expect the dative bond between ammonia and copper. My question to you is, in this compound we need to count the total number of dative bonds and total number of covalent bonds. So each ammonia is providing one lone pair to the copper. In total we have 4 ammonia molecules. Therefore, in total how many dative bonds can be expected? Yes, correct. Anshal, yes, 4 is right answer. We can expect total number of dative bonds as 4. Okay. And in ammonia, as we know, in ammonia we have 3 covalent bonds. Each ammonia has 3 covalent bonds and we have in total 4 ammonia molecules. Therefore, total number of covalent bonds which are present in this entire compound are 4 times that of 3, that is equals to 12. So therefore, total number of dative bonds are 4 and total number of covalent bonds are 12. I hope you are able to get the answer. So with this I will stop for today's session and try to work few more examples based on counting total number of sigma and pi bonds. With this I have completed ionic bonding, covalent bonding and dative bonding, and in between this I have explained the formation of molecules through overlapping of orbitals concept. In next class, we will start hybridization topic. So that's all for today's class. Thank you.